So hello and welcome back. Today we will continue our discussion of the law of conservation of energy, which states that energy can neither be created nor destroyed, only transferred. The way we show this in circuit analysis is power delivered equals power absorbed. So now we have a circuit with an 8 amp current source, a 10 volt voltage source, and 3 resistors, a 5 ohm, 4 ohm, and 1 ohm resistor. So we're going to show that power delivered equals power absorbed by using Ohm's law, which is V equals I times R, and the power formula, which P equals V times I. Remember, power delivered is a negative numeric value. Power absorbed is a positive numeric value. So elements in series have the same current. So 8 times 1 is 8 volts, and 8 times 4 is 32 volts. And elements in parallel have the same voltage. So 10 volts in parallel with 5 ohms is 10 volts, and 10 divided by 5 is 2 amps. So the voltage for the 8 amps is 8 plus 10 plus 32, based upon Kirchhoff's voltage law, so that's 50 volts. So the power delivered for the 8 amp current source is 50 times 8 or 400 watts. Using KCL, I can find that the current of the 10 volt is going to be 8 minus 2, which is 6 amps. So now power absorbed for the 10 volts is 10 times 6 or 60 watts absorbed. Power absorbed for the 5 ohm is I squared R, or 4 times 5, which is 20 watts. And power absorbed for the 1 ohm is also going to be I squared R, which is 8 squared times 1, which is 64 watts. And then power absorbed for the 4 ohm is going to be I squared R, which is 8 squared times 4, which equals 128 watts. So that adds to 400 watts. So power absorbed equals power delivered.